logarithmic differentiation. Logarithmic differentiation is the idea that we're going to use a ln to simplify a crazy derivative before we take the derivative to make our lives happy. It's also how we can solve problems that would have otherwise been impossible to solve. So let's recall our rules. If I have ln a times b, that's equal to ln a plus ln b. So that means that if I have ln of 5x, that's the same thing as ln 5 plus ln x. If I have ln with a bunch of bases and exponents, we want to remember that when we ln something, the exponent comes down and out front. So if we have a question like this, y is equal to 2 minus 3x cubed squared, 6x minus x squared to the 4 over x to the 5, I could use a quotient rule with a product rule inside of it. But I can also simplify it using logarithmic differentiation. So the first thing we're going to do is we're going to take the ln of both sides. So if I take the ln of y, I'm left with ln y. But if I take the ln of the other side, we want to recognize that anything that's multiplication is going to become addition, and anything that's division is going to become subtraction, plus we're going to bring any of our exponents down and out front. So when I ln this entire thing, I'm going to end up with a plus between these two terms, a minus of our x5, and all of our exponents are going to come down and out front. We're just applying our rules of ln. We're not even taking a derivative yet. So I'm going to have 2 ln 2 minus 3x cubed, because that's my base, plus 4 ln 6x minus x squared minus 5 ln x. So we haven't done any derivatives, we just took the ln. And so now, once we've simplified this, we're going to take the derivative. So our derivative of ln y, that's actually implicit differentiation. The derivative of a ln is always 1 over whatever's in the ln. But then what's the derivative of what's inside the ln? We're like, I don't know, it is y prime. On the other side, it can look tricky, but it's just a derivative of a bunch of lns. So this 2 is a coefficient, so it stays there. And then the derivative of ln is going to be this whatever's inside the ln times, what's the derivative of what was inside that? That is negative 9x squared. Plus, my coefficient is 4, so I leave it because it's not on its own. It's being multiplied by something that has a variable. Derivative of ln is 1 over whatever is inside the ln. And then the derivative of what's inside the ln. So my derivative there is 6 minus 2x. Again, my 5 stays, and the derivative of ln is 1 over x. If I wanted to simplify this down a little bit, I could. So I'm going to end up with negative 18x squared over 2 minus 3x cubed plus 24 minus 8x over 6x minus x squared minus that 5 over x. But the whole point here is that I want y prime by itself. So I am going to multiply both sides by y so that I can cancel that out. Now in logarithmic differentiation, we actually know what y equals. It's the original problem. So we sub that back in at the end. So we have that original, that 24 minus 8x over 6x minus x squared minus 5 over x. And then our y, well, our y is just our original equation. That 2 minus 3x cubed squared times 6x minus x squared to the 4 over our x to the 5. And that's our answer. Now, we didn't have to solve this problem this way. It just made our lives easier to do so, okay? Where we absolutely have to use logarithmic differentiation is in the next type of question. So if I have a question where I have an x in both the base and in the exponent, I have no derivative rules that can help me do this. I can't just take the derivative of y equals x to the x. So I have to take the ln of both sides first. So I end up with ln y is equal to x ln x. So when we take that ln, right, the ln of x to the x is going to simplify to x ln x. So now this is something I can actually take the derivative of. The derivative, so all we've done that first step is apply the ln, and now we're going to take the derivative. So the derivative of ln y, 1 over y, right, whatever's inside the ln, 1 over whatever's inside the ln, times, what's the derivative of y? Y prime. On the other side, we need to recognize, again, product rule. We're multiplying two things together. So the derivative of the first, the derivative of x is just 1. Keep ln x plus derivative of, or keep x, derivative of ln x is 1 over x. Just like before, we're going to want to multiply both sides by y. So I end up with y prime is equal to 1 times ln x is just ln x, plus x over x is just 1. And we want to replace y with the fact that we know it's x to the x. One of the questions I get asked about most commonly, because it's my favorite math question, it's also Professor Thompson's favorite math question, is what if it was x to the x to the x? So if we have x to the x to the x, and we want to take that ln, so all we're doing again is taking the ln, we're going to end up with ln y equal to, and when I ln x to the x to the x, the exponent is x to the x. So the x to the x comes out, and I have base ln x. And so I end up on the other side with this x to the x ln x. Now, again, we can't take the derivative of x to the x, except that we happen to already know what that derivative is because we solved it up here. So I can do this. I can take the derivative and I can treat this as a product rule because the derivative of ln y, 1 over y times y prime, what's the derivative of x to the x? We actually have it from above. Ln x plus 1 times x to the x. So if we had this question, we'd actually go and solve x to the x first so that we could use it in our answer. So this is our f prime. We're going to keep that second one, so ln x plus, keep the first, so x to the x, and what's the derivative of ln x? 1 over x. So we have our f, we kept g, we kept f, and we have our g prime. Again, just like any other logarithmic problem, we're going to want to multiply both sides by y so that we can have y prime by itself. And so when we do this, you could simplify some stuff down, but honestly, they're just looking to have y prime by itself. So I've got ln x plus 1, x to the x, ln x, plus x to the x over x times, and what's my y? X to the x to the x.